Thank you. Yeah, so let me share my screen. Okay, so today we're going to be presenting on smart data collection for sensor networks. Before we start, just some housekeeping. Hopefully all of you have access to Mana. You should all have temporary accounts if you if you don't actually have a permanent account for that. If you don't for some reason, we're just going to be using that to access a Jupyter notebook. So alternatively, you could use Google Colab or something else to run it, but hopefully you all have access to that. If you haven't had a chance already, we're going to be using a Jetstream virtual machine as well as a Tapas account. They have the same credentials. So there should be a spreadsheet that I received an email for. I'll also drop it in the Slack. I'm not Slack, sorry. The Zoom chat. So if you haven't already signed up for one, it looks like this. Just go ahead and put your name next to let's have credentials. This is the Tapas Trang URL that we're going to be using, and then the storage system. If you want, feel free to SSH into the storage system. Just make sure that you do have access to it. Then finally, if you don't have a Discord account, a bit later on in the workshop, we're going to be using Discord just to demonstrate some of the uses of Tapas streams. So here's the link to the Discord server that we're going to be using. And so go ahead and sign up for Discord and join the server if you haven't already. So I'm going over a brief introduction to Tapas and the Streams API, which we're going to be using primarily today. So generally, what is Tapas? Tapas is an NSF-funded open source scientific framework. It's a collaboration between the University of Hawaii and the Texas Advanced Computing Center. So it provides a framework for people from different domains to access a set of remote computing resources and deploy software workflows and access storage systems, and provides database storage and a bunch of different resources for researchers to use. It's provide as a set of APIs or application programming interfaces, and it handles authentication and authorization to all the resources that handles. And so we have the EQI Gateway and the Hawaii Climate Data Portal are currently built on Tapas, as well as a number of other scientific gateways. So for the API services that provides, there's a few different general groups of them. First one is tenancy authentication and security. So tenants provide a general set of resources that you can access. You authenticate into a particular tenant, and it provides you with the resources that are available through that tenant. There's metadata management. So these are kind of the backend databases that it uses. There's the metadata API, which it uses a Mongo database, which is a NoSQL database for managing a lot of metadata resources for, say you deploy a job, you can use it to get information about how the job ran. A lot of that is stored in the metadata service. It also has a PGRUS, which is a Postgres service, stores JSON documents. That's a more traditional SQL database. Tapas allows you to access remote data management and code execution tools. So there's the systems, files, apps, and jobs APIs. So basically, systems is storage and execution systems that you can use to store files and data that you're using, as well as execution systems for actually running those jobs. Files gives you access to files that are stored on most storage systems, applications for running applications and workflows, and then jobs for actually creating workflows using the applications. And then there's also streaming data, events, and functions. Is a lot of what we're going to be using today. So you can create functions, which we call actors, basically containers that you're able to run, and you're able to trigger them in different ways. I'll go over this a bit more later. And then streams, you can put data. So where this workshop's on sensor station data, so you can put in sensor station data from real world sensors as it comes in, stream it into the system. So I'm going to briefly go over a few concepts that are fundamental to TAPIS, APIs, REST model, and then JSON. So what is an application programming interface? Basically, it's an intermediary that allows applications to talk to each other. It's language agnostic. So if you have an API that's written in, say, Python, you can interact with it from JavaScript. It's generalized enough that you're able to use it from anywhere. And it's used by most of the web. Generally speaking, if you're interacting with a website, it's going to have a backend API that handles requests and provides the information that you're viewing. So REST, or representational state transfer, is the architectural style that's used for most APIs and web applications. It's not actually a standard, although it's pretty much ubiquitous across any web application that you're going to be using. It's a stateless system, so basically you request something from a server. Server provides information back to you on whether it was successful, what happened. There's a set of codes that it provides to say, either this was a successful operation or you aren't authorized to do this, etc. And then JSON is JavaScript object notation. So it's a human readable data interchange format. So as opposed to a lot of languages might use kind of obfuscated object language. So if you were to, as a human, try to view the object, you wouldn't really be able to tell what it contained and what was in it. JSON is string based. So basically you have a set of key value pairs, and it's to use. APIs typically use that to interact with each other, just because it's a easy to use standard and it's easy to understand what's going on. So for the TAPIS data management and code execution APIs, TAPIS provides access to high performance computing systems, high throughput computing systems, as well as cloud storage and other cloud resources through the systems, files, apps, and jobs APIs. So it lets you register storage and computational resources, and you can ingest data into them, transform the data that you're using, and as well as interact with the files that are stored, move them around on the system without actually having any knowledge of the underlying storage system. And you're able to register applications on systems. TAPIS takes care of a lot of the backend deployment details, so you can deploy a task on HPC system without actually having to interact with scheduler or do anything like that. And it also enables you to do real-time complex workflows. So basically, if you have a specific set of tasks that you want to kick off another set of tasks, you can set that up in using TAPIS. So you can have an event system that basically, if some specific event happens, you kick off a set of tasks, and those set of tasks can also kick off more tasks. So you can create large, scalable, complex workflows. So the Abaco actor system, which we are going to be using today. So it's a function as a service system. So you can define an actor using a Docker image, so a containerized image, which basically stores information about the runtime environment that you want to run on, as well as the actual code that you're going to run. You can register that with Tapis, and then you can send messages to the actors. So you can trigger it when the container receives the message, then it can use that to run a task. It asynchronously launches the container in the background on the storage system that you, or the execution system that's set up. You don't really have to worry about where it's running. It's all managed by whatever site the intent belongs to. So we're going to be using a TACC-based tenant today. So basically it's going to be running on their execution system somewhere. And actors also provide a lot of job provenance information. So it stores all the information about what happened while the job was running, and you can get that back and view information about it. So the Streams API is new to Tapis version 3, and it provides basically a method for creating a virtualized sensor station, which you can connect to an actual real-life sensor station network. So let's say you have sensor stations collecting climatological data, say rainfall data, which is something that we use a lot, and stream data into the Streams API by setting up measurements, and we'll create a virtualized system later on. That's part of the workshop. Either the sensors can directly provide the measurements that they collect, or the sensors can interact with the gateway that then streams the data into it if you want to do some pre-processing or something like that. That is provided to Tapis, and then it goes on into it being stored in the metadata service and core server, and can be served out through set things. You can set up hooks to, or you can set up triggers. So let's say your data surpasses a certain value, you can then kick off a task, or you can just kick off a task every time it receives data if you want to. So generally, how are we using Tapis currently? There's a number of gateways that are set up for it. The University of Hawaii actually has a few, CMIEK, which is a microbiome gateway, EQI, which is our sustainability project, as well as the Hawaiian Climate Data Portal, which is a data portal for viewing, visualizing, and exporting climatological data, so rainfall, temperature. We're working on vegetation index data and a bunch of other things. And that leverages Tapis heavily to store that. In terms of actually interacting with Tapis, because it is an API, you can interact with it via curl calls if you're familiar with that, or there's a command line interface that's set up over the curl calls for interacting with it from a command line. As well as a few different libraries. There's tapipy, which we're going to be using today, which is a Python library for wrapper around the APIs that you can use to interact with them. There's also a TypeScript library that's available. So the metadata API is actually leveraged heavily by the Hawaiian Climate Data Portal to store information in a Mongo database. Basically provides wrapper around a Mongo database for, and tags any documents that you put in. So it's a JSON-based database. Tags and documents that you put in with unique identifiers, so you can find and retrieve the data. You can also query it based on the actual information in it, similar to a traditional SQL database. And it's also been designed to support spatial querying. So if you have geographical data with a latitude and longitude, you can say that you want data that falls in a specific area, and it will retrieve that for you. So going over workflows and containerization, generally, what is a container? What do you use it for? It combines all the dependencies for a specific piece of software that you need. So everything from the base operating system to code, any libraries and dependencies that it requires. So it allows you to run it on multiple systems without having to worry about the underlying architecture of the system. So if you have a set of Linux programs and you want to run it on a Windows system, if you're running it through a container, it doesn't matter because it's completely separated from the underlying architecture of the system that you're running it on. And it also helps if, say, a package that you're using updates and it breaks and causes cascading issues that break other parts of your workflow. If you have a specific version of the package set in the container, it will always use the same one. So it's good for reproducibility. Kind of went over this already. So portable allows for reproducible environments so that no one's get the same results. And you can tag versions that you create so you can go back and forth if something goes wrong. And so an example of how that's used is for the Hawaiian Climate Data Portal, our rainfall mapping workflow. Originally, we didn't have it containerized, and it makes it very difficult to scale because you have a lot of moving parts and a lot of libraries that relies on a lot of dependencies that could change and cause issues in between the very different components if there's incompatibilities. So for this specific mapping workflow, we have data acquisition, machine learning system that takes all of the data and does QA, QC processing, performs gap filling on the data, aggregates all of the information, and then interpolates the data from various sensor station points into cohesive maps that provide rainfall or temperature data for every grid point across the state. So yeah, there's a lot of moving parts. Containerization helps to alleviate some of the challenges by taking each component, containerizing it so that they're kind of isolated from each other, and they won't cause cascading issues. If something goes wrong in one, you can fix the issues and not worry about the rest of the workflow. So this is, all containerized in using Docker. Docker Hub is a repository that stores the container images. And then we use Tapis to actually push up the files that we need into our production system, and JustStream is used to run the actual jobs. So for the Tapis container workflow development, we're going to be actually doing a portion of this today. So the kind of top portion where the user to Jupyter notebooks into Tapis is something that we're going to be running by creating a virtualized sensor station using a Jupyter notebook. And then that will, one of the things that we're going to do is deploy Abaco actor using Tapis that runs a very basic workflow based on the virtual data that you put into it, and then returns information on that. And that's a container that's that has been created. So for automation with Tapis, there's a few different ways that you can trigger actor. The one that we're going to be doing today is a threshold-based system. So basically, if I receive data that's over a specific threshold, then kick off a job. But Abaco provides several different ways of actually kicking off these jobs, including a built-in cron scheduler. So that's something that's used heavily by the Hawaiian Climate Data Portal because we have a near real-time workflow essentially that runs at a daily and monthly timescales. So essentially every day we can set it to at a specific time, run a set of tasks and fetch data, run a set of tasks, and produce the output that we use. Yep. And so that's it for kind of the basics. Just some more details on the Streams API specifically, because that is the main API that we're going to be focusing on today. It kind of relies on a hierarchical structure. So there's a concept of projects, sites, instruments, variables, and measurements. So projects are kind of the top level overarching object. You can create a project. Within that project, you can create multiple sites, which would be field locations where you have sensor stations located. Within those sites, you can have multiple instruments, so multiple sensor stations that do different things potentially. Variables, so you can have a sensor station that reads soil moisture content, that measures rainfall, that measures temperature. So you can register those as variables within your instrument. And then finally, measurements are the actual kind of core of the system, the actual data that it's reading. So you provide a set of actual values for the different variables that you have set up, along with date time saying, no, this is when I got this data. And that's what is actually used to trigger workflows, or that's what's actually stored as the data that's coming in from the sensor stations. So Abaco containers, I went over that. We're going to be using a trigger system. Basically, you register a channel which defines a specific threshold. So when a measurement that is received hits that threshold, then kick off an Abaco container, which it basically sends a message to that Abaco container and then kicks that off. Yep. And now I'm going to pass it off to Dathy, and he's going to go over actually deploying the Jupyter notebook and running the Jupyter notebook.
Awesome. Thank you, Jared. All right, let's get started on the workshop. So we're going to be on section 2 here. And so first things first, you have you guys log into your Mana accounts. Once you log in, you should arrive at a page that looks something like this. It's just a nice friendly reminder not to misuse the resources. Very 1 second for that. Great, and so once you're in there, we're going to go up to our interactive apps and start a Jupyter notebook. So we're going to be in the workshop partition, 2 hours, 1 core, 6 gigabytes of RAM. We don't need a GPU for this. And once you have all that filled in, just hit launch. And then once your notebook is ready, we can go ahead and connect to it. It's like everybody's pretty much there. All right, so the next phase we need to do is we need to install our non-basic library. So that's our tapipy. So if you go over into the third module here, and go down, we're gonna have 2 commands that we're gonna run on the terminal. This first is the install the tapipy. So when we're over in our Jupyter notebook, we'll just go to new, terminal, and then we go ahead and install tapipy. Then once that's complete, or go ahead and grab the notebook that we will be using. So just go a little bit farther down to module 3 and get the Git address for that. Go ahead and also paste that into our terminal. Once that's complete, we should see a notebook folder now in our Jupyter notebook. And we can go ahead and open that up. And we're a little ahead of schedule, but given the next section, we're going to go ahead and take a short bio break. If anyone needs to use the bathroom or grab water, we'll come back in 5 minutes. All right, so let's jump right into this notebook. So the first thing we're going to do is go ahead and import all of our relevant libraries. And then we're going to connect to Tapas. And so this is where you're going to need to use that username and password that are on this Google Sheets. So obviously any one of these with a participant already next to it is taken, but if you haven't gotten one already, just grab one of these open ones. And wait till that completes and is good. Incorrectly enter your password like I messed up. Let's go ahead and check our access tokens. It says all of our relevant information with that. It kind of verifies that you are logged in. And then we're going to create a unique ID on this, and every unique ID does need to be unique. So right now we're just putting in the time associated with your username to make it a unique ID for this particular workshop. So there's my username, and then followed by a unique identifier. And then we'll go ahead and create some relevant variables we'll use later on. So back to what Jared was talking about. We have this hierarchy of things. So we're going to go through and make the relevant hierarchy for this particular example. So we'll make a project with the project ID, our username and password, set it to active, and we don't have any metadata associated with it, but that would go there. Let me just look at the return from that create project call. Next, we'll create a site. That again is the return from the create site call. You'd enter all of your relevant information, say if this is a different sensor somewhere else, but feel free to change those values if you want to play with it and see what happens. Next, we're going to create an instrument. This is where we create our instrument ID and a description of it. So, here you might have a relevant description for this is the sensor up in the allows, and it is going to measure blah, blah, blah. And then down to where these variables, and we're going to define what we're actually measuring. So our variable name, rainfall, our variable ID, which is also rainfall. We can enter in our units and any associated metadata with that. And once again, we can look at the return and call for that.
What is this course? Course has like course ID on the variables and then like for.
I don't know, Jared. What is the course ID referring to?
That specifically, I'm not entirely sure.
I know this. So
Thanks, Sean.
the stream service, we developed it leveraging. So there's an open source project called Chords that was developed with what is it? Earthcube. It was a project out of Earthcube, and it was basically for storing and serving out some sensor data. And so we leveraged a bunch of the data schema and some of the things behind Chords and integrated some of their services when we built in the tapestry stuff. And so we make some Chords objects on the back end. So the Chords ID will map to those, so that if someone wants to at some point export data out of the stream service and just have a standalone Chords service, that is something that we're working on supporting as a like a dissemination endpoint. So that's why we have some integration for Chords.
Yeah, thanks.
Super helpful. Thank you. Okay, so next we're going to create some random sensor data. This is where you integrate it to whatever sensor that you have, as long as it's able to connect to the internet and make these calls. But we're just going to go ahead and generate 100 random points for both rainfall and temperature, and append the date time. Okay, and at the end of that, we added it to our stream here with this create measurement call. So next, we are going to download that stream data and view it. So here we can download it in various formats. We're downloading it now as a CSV, which is super convenient for a lot of libraries, but you can also download it as a JSON or a text file. Those are the three that I played around with and tested. So we can change this and view it as a JSON output, which is a little bit more readable. We're just gonna glance at it. Or we can go back to CSV. Then we can use a library like Pandas to pull it in and read it as a data frame and do various operations on it, which are super handy. And then from there, we can also visualize it as a plot. But the important thing to note here is that this is all coming from Tapas. This isn't just locally stored variables. This is right here. We actually go and get it from the Tapas service. So next, we're going to go over storage. So we need to create a system ID and then do our system config here, where we define the host is, the description, our system type, and then our authentication method. Go ahead and do that. The URL for it. We're going to add our login credentials we have from earlier, created earlier in the notebook. See here that we successfully got that in. Then we can go ahead and kind of interrogate the system here and list the files that we have sent up. And there's the file, the associated metadata with the file, and then the URL to access that file. And then this is kind of this is my own personal taste on this, but I think these thresholds are kind of the most interesting thing to me. I come from an agricultural background, And I can think of a myriad of ways to use something like this, but I'll go into that a little bit later when we go into integrations. But we're going to create an actor so that we can execute threshold triggers. And we can view the response that comes off of that. Then view our get actor response with all of the associated information for that. And here is where we're going to create this threshold trigger, where we're going to find the trigger actions here, and then we're going to define the conditions for that. So here we define when temperature is greater than 100, we're going to trigger this the actor to take action, and then we can define what that action is and the message to post when it does. And then here we can list the channels, demo tapis, check ID, various endpoints. All of the information associated with that. So next, we're going to go ahead and create a measurement that's going to trigger our alerts. So we're going to go ahead and just put in a temperature of 230 degrees, which is above our 100-degree trigger point. And this is asynchronous. So if you go ahead and click through the next cell and you don't see anything, like right here, that means that this just hasn't gone through yet. So we need to wait a little bit, and we'll keep checking this. Otherwise, the next couple of cells will run invalid code. Okay, there we go. There's our alert.
So an actor could be any custom method you play, right?
That I believe so, within the allowable triggers. So there's that threshold trigger, and Jared mentioned there's temporal triggers you could put. So like once every month, once every week, execute and function.
We also just recently added in dead man checks. So you can make it so that if say your sensor station didn't report for, if it was supposed to report every 15 minutes and doesn't report something for half an hour, then you can have a trigger as well.
That's helpful. Cool. Okay, so then we're going to just store that alert variable, fetch the execution log. This has everything that happened. And then lastly, view our files we have on the virtual machine. So then we can download these files. And so for this section, we're going to download this last image here, which is of that, that plot we made. So it's all going to be unique depending on the timestamp when you actually executed the code. So we're going to go ahead and just take this last bit of the path and put it into this section here. That way we can actually download the relevant file. And then as you can see, we can visualize that this PNG is living in the folder that our Jupyter notebook is living in, but you could have it go wherever you'd like. By this, I believe. Okay, and so here's kind of where I think at least, you know, this might not be super exciting for a lot of academics, but if you're doing any work where you're integrating with people on the ground, I think this is where it could be really cool. And so circling back to what I was talking about with my background in agriculture, I could absolutely see where you could set up a sensor network inside, say, a greenhouse or outside in your field, and you could set up various actor triggers with this, such that you could, if the greenhouse is exceeding the temperature limit for whatever you're growing in the greenhouse at that time, and your normal environmental controls are not keeping it adequately, you have these integrations to Discord or Slack, and have push notifications to your phone, so you could literally have your phone ding at you when the greenhouse is about to kill all your plants. And I think things like that are just extra neat to me. So this is where we're going to demonstrate that. This webhook URL here is specific to the Discord server that we have, but you could set up a webhook in your own Discord server and get your own webhook URL and put it in there so that it would stream to your individual Discord channel. But we're just going to go ahead and use the one for this workshop here. And then write those channels to the Discord server. And then we can do, guys haven't already gone there, if you go back to the very first page on the workshop and go to preparation, then go, if you've already signed up for Discord, you just hit this join Discord server, open up the app, and we can see here everyone's various triggers that are coming in to the Discord channel. And this happens real time. So if you go back and run that last cell, you should see another notification pop up in Discord, just like that. All righty. That's all we got for the notebook, and I'm going to turn this back over to Jared to talk about a pretty slick React UI that they also have for this.
Thank you. Okay, so the last thing that we're going to go over today is Tapas UI, which is essentially just a user interface that was built using React that leverages the TypeScript library for Tapas. And basically it provides a modular web application for interacting with Tapas through a user interface. So you don't actually have to code things in. For the streams stuff right now, we don't have any way to actually insert data, although you can view the data that you just inserted. So if you go to this module, there's a link to Tapas UI. Log in with your user credentials that you used for Tapas. And then once you do that, you should see either you can go to it from the sidebar or through this. It shows, and so I have 9 projects for my personal user. You probably have 1 just from the current workshop. So you can go in that and then select through the instances that you create. So first select project that you want, then site, and then the instrument. And finally, it will show you the variables and the measurements that were created for that. So this is collapsed because there's a large number of them. You can also view a graph of it, and this is using Plotly, so you can zoom in, and you can also download this plot as image if you want to. And yeah, that'll create PNG. There's also the ability to filter the data. So I can say, let's say I only want the last 10 measurements. I can do that. It'll reload and I'll just give them the last 10 measurements that were created. You can also create date limits. So if I say I just want for the dates actually are for today, the 23rd, and then up to 24th. Oh, sorry, that was, there we go. They were before 12 a.m., so it didn't trigger, but yeah, you can filter the date range. You can also do an offset. So if I wanted to do a limit of 10, but offset from the start by, say, the first 10 values, then do that. So basically, this just provides an interface for querying the data, and then you can view graphs and the actual values that came through without having to use Python or actual coding to do it. That's about it for that. The last portion is we have an assessment where we are a bit ahead of schedule. If anyone has any questions.
I just wondered about time zone support. Like, is everything in UTC on the back end, or how do you handle different time zones?
I believe everything on the back end is UTC. So these were actually created yesterday. Or today is the 24th. Yeah, everything that's stored should be UTC.
So like if you have a sensor in a different time zone, is there some configuration that you enter to tell it the offset from UTC for it to ingest the data?
So when you define the data, it actually asks you for the value. So you put in the daytime value when you put in the measurement.
Yeah.
So you can't put the daytime value in whatever time zone you're using.
Okay.
I think, yeah, for this example, we're just using UTC, but it is possible to create your own custom if your sensor station has a time zone offset. And this is the ISO WIN 601 format, so I believe you can actually build in a time zone into that.
Okay, thanks.
Any other questions? Oh, there's some stuff in the chat. Okay, Sean answered that. Okay, yeah, if that's everything, then I guess we can go ahead, and if you don't mind taking a few minutes just to go over the assessment, that helps us out a lot. And other than that, thank you for attending.